Yeah, guys. Okay, let's handle this question. Right? Okay. So 49th questions, page number 201 from the HC Verma, the current electricity, right? Yep. The voltmeter shown. So the voltmeter has been connected across 50 ohm resistor, right? This is the voltmeter. Okay. So it has been given that 18 volt, right? The voltmeter reading is 18 volt. That's actually measured the potential difference across 50 ohm resistor, right? So voltage drop or potential difference drop or potential difference across 50 ohm resistor. 50 ohm resistor is 18 volt. That's what the voltmeter reading shown. So voltmeter must have got some resistance. So we will say that as, okay, so RVR, some R. Mm, yep. So if this is some R, yep. So across this 50 ohm, it is 18 volt, means definitely across 24 ohm, that is 12 volt. So it has been mentioned 18 volt across 50 ohm resistor, which means the remaining voltage drop definitely across 24 volt. Am I right? Of course, you may take the current direction like this. So cool. Right. Okay. So we must take some resistance R for this, okay, for this voltage as well. Sorry, for voltmeter as well. Across which you can see a potential difference 18 volt. So we already know 18 volt potential difference. Okay. So, for example, there is a current flowing through this 50 ohm resistor. I50 into I is voltage is same, no? So 18 volt is equals to I into R. I50 means current flowing through this 50 ohm resistor into R. That's also equal to current flowing through the voltmeter IV into its resistance R. So easy, right? And we know the current flowing through the 24 ohm. So easy, no? Let's find out the current flowing through the 24 ohm. I24, which is nothing else, the total current. I total is equal, I is equals to V by R, 12 by 24. So whatever the total current which is delivered from the source first flows through the 24 ohm, the total current at first flows through the 24 ohm. That's going to be divided between 50 ohm resistor and also voltmeter, right? So the total current is actually 0.5 amp, right? That total current is going to be divided between 50 ohm resistor and also voltmeter resistance. Okay, so let's find out I50 first, the current flowing through the 50 ohm resistor. I50 ohm is equals to 18 by 50. 18 by 50 means 0.36 because 1.8 by 5. 1.8 by 5. 0.3 is a 15. 5 6 are 30. Yeah. So you got 0.36 amp. If I50 is 0.36 ohm, however, voltmeter IV is I total minus I50. What is the total current? Why do we have to do this? We know the total current flows through the 24 ohm I total current flows through the 24 ohm first and divides at this particular node between 50 ohm and voltmeter. So I voltmeter is definitely total current minus current flowing through the 50 ohm. Yeah. 0.5 minus 0.36. So this is 0.24 amp. Yes, you're done. So, 18 is equals to, from this equation, 18 volt is equals to current flowing through the voltmeter into its resistance. We already got IV is equals to 24 amp. I is equals to 0.24 into R. This is the resistance of voltmeter. R is equals to 1800 divided by 24 for simplification, right? 300 by 4. It's gonna be 4 sevens are 75 ohm. So voltmeter, the resistance of voltmeter the resistance of voltmeter is equals to 75 ohm. Okay. So please observe what I did. At first, as soon as I got, and as soon as I understood the potential difference across 50 ohm is 18 volt, I understood that the remaining voltage drop definitely across 24 ohm. So current flowing through this can be found by V by R. I is equals to V by R, 12 volt by 24.5. So zero point 0.5 is the total current which is delivered from the source. So that zero point 0.5 definitely divides between 50 ohm and voltmeter based on their resistances. So we already know 18 volt across voltmeter means as voltmeter and 50 ohm both are in parallel, definitely potential difference across these two are same, right? So again, you can find out the current flowing through the 50 ohm. I is equals to V by R again, 18 by 50, that is points. So out of 0.5 amp, 0.36 amp is flowing through the 50 ohm, and remaining 0.24 amp is flowing through the voltmeter. This we got 0.36, right? Now you're done. Again, R is equals to V by I. 18 volt divided by I. That is 75 ohm. So easy, right? Okay. Yep. I think we better get another one. Next question, as it is so easy. Let's complete 50, question number 50 also in the same slide. So for that, 50. Okay. Yeah. Question number 50 is here. Okay. Right. A voltmeter consists of 24 ohm coil connected in series with 575 ohm resistor. The coil takes 10 milliamp for full scale deflection. What's the maximum potential difference? So easy, if this is a voltmeter, let's say it has some coil and 25 ohm resistance. So let's say it is voltmeter and it has been connected with a resistance. Resistance symbol is not proper. So yeah, what's its resistance given? 575 ohm. So the question is asking, the coil actually taking how much current? What's the current is received by the coil? 10 milliamp. It's so easy. 10 milliamp. So definitely the same 10 milliamp flows through the 575 ohm as well, right? So the total voltage, so whatever the potential difference across you can see between these 2 points, okay, PD across you can see between these 2 points is the potential difference measured, that the voltmeter can measure. PD across this is actually the voltage. that voltmeter can measure. Okay, right. Hmm. The voltage that voltmeter can measure is nothing else potential difference across coil and the series connected resistance. So the total resistance R total is, let's find out the R total of this branch, 575 plus 25, that is 600 ohm. The current flowing through these two resistors, as these two have been connected in series, the same current flows. So 10 into 10 power minus 3 amp. And then obviously the voltmeter, the same, the voltage that voltmeter can measure is I into R total, right? This is equals to I into R total. The current is 10 into 10 power minus 3. R total is 600. So ultimately, the voltage that voltmeter can measure is equals to V is equals to 6 volt. You can keep this in a box, right? Yeah, these are the two questions. You can copy to your classworks. Okay, so easy, right?